Hey guys, happy post Thanksgiving. Can you hear me okay? Oh man, I swear, you take a few days off and you stop shaving for those days and man, you get a full-grown beard like this. I'm telling you. Right now we want to focus on section 7.3, quadratic forms. So in this section, we're going to be studying functions, which include square terms and or these things called cross terms. So far, for the most part, our course has been devoted strictly to uh, linear equations or equations that have what's called a linear form in n space. And here are a few just quick and easy examples of linear equations. Going back to our very first section of notes, the tall tale sign that you're working with the linear equation is that all the variables present in the equation have a degree of 1. Or in other words, each term or each monomial involved in the expression has a degree of 1. So if you look at example part A, our variables are x and y, and each of those variables have a power of 1. Equation B, x, y, and z all have a power of 1. And for equation C, x sub 1 has a power of 1, so does x sub 2, so does x sub 3, and so does x sub 4. So that was our quick and easy way of identifying whether or not an equation was linear. These would be said to have a linear form. We're going to up the ante a little bit, starting in this section, by studying equations that are said to have a quadratic form in n-dimensional space. So just looking at these upcoming 3 equations, it's probably easy to tell why they might be called quadratic form equations. If you look at the degree of each of the variables, say in example part A, the variables involved are x and y, and each of those variables have a degree of 2. Now something such as the equation in part B would also be considered an equation that has a quadratic form. And even though it doesn't look like x sub 1 and x sub 2 have powers of 2, the term itself does have a degree of 2. So x sub 1 has a power of 1 and x sub 2 has a power of 1, but the degree of this term, this product of x sub 1, x sub 2, I'll write it this way, degree of x sub 1, x sub 2 is equal to 2. Now, if you don't know this fact, I'll go ahead and shed some light on it now. There is a more general definition of the degree of a monomial. The degree of the monomial basically counts how many variables are involved. So for instance, with x sub 1 and x sub 2, we've got 2 variables involved, and that would be the reason why that has a degree of 2. So long story short, x sub 1 times x sub 2 equals 1 is an equation that has a quadratic form. Now if you look at the equation in part C, this is also something quadratic in form. X sub 1 has a degree of 2, x sub 2 has a degree of 2, and then here we have it again. We have a monomial, in which case there are 2 different variables, so that term also has a degree of 2. So in short, we're working with equations that have degrees of 2. Now there is a special way of writing these quadratic form equations using matrix multiplication. And we're going to do a little toy example here, which illustrates how you could represent one of these quadratic forms as a product of 3 matrices. Now, let's take a look at these matrices and maybe dust off the cobwebs with some facts regarding matrix multiplication. If you look at the first matrix, we have a row vector consisting of variables x sub 1 and x sub 2. Right after that, we have a 2 by 2 consisting of what are assumed to be real numbered entries. And then the very last matrix here is a column vector using the same unknowns x sub 1 and x sub 2. Now this is kind of a funky product we're looking at here, but as you'll see, it's what we need to write. It's the format we need in order to write a quadratic form equation using matrix multiplication. Now, I do want to check that the multiplication does work. So for instance, the size of the first matrix is a 1 by 2, and that's getting multiplied to a 2 by 2. And the end result of all that is going to get multiplied to a 2 by 1. So if we were to begin this multiplication, one way of doing it would be to multiply the first two matrices together, and notice that the inner numbers match. So this multiplication is defined, and the end result of it should be a 1 by 2. So then what happens is we take this 1 by 2 and we multiply it to the 2 by 1. And you'll notice that the inner numbers would match again, so the multiplication of that is defined, and the end result of that multiplication would be a 1 by 1. And this 1 by 1 can be treated as like a scalar, in the sense that we really wouldn't need the matrix brackets anymore if we come across a 1 by 1. So what we'll do is carry out this multiplication as far as possible until we get down to a 1 by 1, and we'll see how this product of these three matrices in this format would yield a quadratic form equation. So let's start with what I have in parentheses. We're going to take the row x1, x2 from that row vector and multiply it to the first column of the 2 by 2 matrix. All right. So what happens is we multiply x sub 1 to a, and I'm going to write that as a x sub 1. And then we multiply x sub 2 to b over 2, and I'm going to write that as bx sub 2 over 2. Now, this is going to be the first entry of a 1 by 2. So to make it look like it's an actual entry versus like 2 columns, I'm going to put parentheses around it. And right after this is going to be our second entry, in which case we take the row vector x sub 1, x sub 2 and multiply it to the second column. So that's going to be x sub 1 times b over 2, or bx sub 1 all over 2, plus cx sub 2. And that is our second entry in this 1 by 2. So far, so good. All right, so just want to emphasize that this is a 1 by 2. It could look like a 1 by 4 because of the 4 terms that are involved. But this is now going to get multiplied to this last matrix, which is a 2 by 1. And as mentioned a little bit ago, this will result in a 1 by 1 matrix, in which case we can just kind of treat it as a scalar by removing the matrix symbols. So how are we going to multiply this out? We're going to multiply the first entry of each of these matrices together. So the first entry of our 1 by 2 is going to get multiplied to the x sub 1, and the second entry of our 1 by 2 is going to get multiplied to the x sub 2. So let me write it out this way. I'm going to write x sub 1 times the quantity ax sub 1 plus bx sub 2 over 2, plus x sub 2 times the quantity bx sub 1 over 2 plus cx sub 2. What I'd like you folks to do is take the next minute or so to simplify everything. Start by distributing what's in front of the parentheses, and then if there are any like terms, go ahead and combine them. And you can also remove the brackets at this point because it's a 1 by 1. All right, so go ahead and simplify this as far down as possible. And after a minute or so, I'll jump back in and we'll go over the results. Ready? Here we go. So I'll distribute x sub 1, clear those parentheses. That's going to give us a x sub 1 squared plus, and I'm going to write it this way, b x sub 1 x sub 2 all over 2 plus, and clear parentheses by distributing the x sub 2. So we'll have b, and I'll write that as x sub 1 x sub 2 all over 2 plus c times x sub 2 squared. So we start to get some square terms here, and we actually have a couple of like terms, and that would be the two middle terms involved. If you add those together, you get the following: b x sub 1 x sub 2, and of course you can carry down the rest. So ax sub 1 squared plus that bx sub 1 x sub 2 plus c x sub 2 squared. And this is definitely one of those types of quadratic form equations. Okay, every term involved here has a degree of 2. So that's a result of the special format of this multiplication that we started out with. And that format of this quadratic form that involves the wacky product that we started out with is known as the quadratic form associated with a matrix A. So it says here, in general, if A is a symmetric square matrix and X is a column vector of variables, then we define a product such as the one above as a function. And here's the notation for that function. It's capital Q. It probably makes sense as to why, right? Quadratic. And the subscript is referring to the middle matrix that's involved, which if you look at the middle matrix that was involved, you can tell it's symmetric because here's the main diagonal, and the terms that are off the main diagonal are mirror images of each other. So that middle matrix is symmetric, and when you write a quadratic form equation using this format, the middle matrix always will be symmetric. And the product itself it involves the transpose of our column matrix of unknowns. So X transpose times the symmetric matrix times the original version of the column matrix of unknowns. So the reason why it's X transpose AX is because we need that first matrix to be a row vector in order for the multiplication to work. So this function is known as the quadratic form associated with the matrix A. And always keep in mind that that matrix A is going to be symmetric.